These powerful little speakers are made with a translucent flax fiber housing that allows them to light up and give off a beautiful ambient light. Hi, I'm Roman, and in this video I'll show you how I built them. The speakers were going to be powered by these two powerful and nicely looking 20-watt drivers, which I got from an unused pair of speakers from an old stereo system. They were going to be powered by this tiny stereo amplifier, which has a built-in 3.5mm audio plug, as well as a Bluetooth antenna, and can deliver 30 watts per channel. The true stars of the show, however, were going to be the illuminated speaker housings. This was possible due to the translucent nature of certain flax fiber composites, which usually show off their natural brown color, but when backlit with a light source, display a beautiful optic showing the flax fibers. To build the housing, I used a mold that was originally designed for lampshades. Because I really liked the shape, I repurposed it to serve as a template for the speakers. I gave it a nice polish with mold release wax, which would allow for the part to be easily demolded later on. For the layup I used ±45° flax fabric and cut 4 layers for each speaker. To produce a nice sound, the speaker housings should be quite heavy, but it was going to be a compromise between weight and still allowing for enough light to pass through the housings to illuminate them. I started with the layup by applying spray glue to each layer and carefully placing them in the mold. It was important that all layers were going to be joined in the same place that was later on going to be the bottom of the speaker, because the overlap would be visible as darker area when the housing is backlit. When I was finished, I cut off the excess fabric and prepared the mold for the vacuum infusion. I put tacky tape around the rim and placed a tube for the resin inlet on top of a piece of release fabric. A membrane tube connected to a hose was used to pull the vacuum. Finally, I applied the vacuum bag and carefully pulled the vacuum step by step. At the same time, I had to make sure that the bag was properly placed and that there were absolutely no leaks and the part was completely airtight. The part was now ready to be infused, so I mixed the resin, placed the inlet tube in it and opened the clamp to start infusion. The resin slowly started propagating through the fabrics towards the vacuum hose. It took about 10 minutes until the resin front reached the end and the entire part was infused. I clamped off the inlet and the vacuum hose and let the part to cure for about 48 hours at room temperature. To demold the part, I removed the vacuum bag and all the hoses. With the help of thin wood sticks and compressed air, I freed the part from the mold and took it out. After making the second part, the housings were now ready for further processing. The next step was to cut the housings to the desired shape. To do this, I first needed to determine the final volume of the speakers. I wanted them to have a volume that was similar to the previous speakers, which was roughly 1.2 liters. So I measured the same amount of water and poured it into the composite part. With a tape I was then able to mark the water line. I placed a pencil on a couple of spacers to the marked height and drew a nicely horizontal cutting line around the entire shape. To make the cut I used an angular grinder and very carefully cut along the line. Next I needed to sand down the rough edges on a flat surface until they were perfectly smooth and level. This was very important to get a nice fit with the front panel. Now that the housings had their final shape, I could copy it onto a 16mm MDF board that was going to be the front panel. Using a jigsaw I cut the shape, leaving a bit of an edge to perfectly finish it later on. I marked the center of the front panel and drew a circle for the necessary cutout for the driver. Then I first drilled a couple of holes and cut out the circle with the jigsaw. At the friend's workshop, I was sanding down the front panels to their final shape using an edge sander. With a router I milled a rounding with a 10mm radius that was going to match with the rounded shape of the composite housings. On the backside of the panel I milled a small notch that was going to help to accurately place the front panels onto the speaker housings. The last thing that was now left to do was to mark and drill the holes for the volume and the light controllers on the main speaker and the screw holes for the drivers. I sanded the MDF parts and painted them with 2 coatings of spray paint. I chose the green color because I was going to use the speakers together with my DIY computer case, where I used the same materials and color scheme. While they were drying, it was now time to start with the electronics. The left speaker was going to house the amplifier as well as the volume control and the light controller. To control the volume, I used a dual gang potentiometer with a built-in switch, and for the LED lights I used a pulse width modulator with a frequency of 10,000 Hz, which also had a built-in switch. Both speakers of course were going to have a driver and LED lights built in, which were going to be connected with cables to each other. First I put the amplifier on 4mm plastic standoffs, which were going to be helpful for cable management, as you're going to see later. As always, you can find links to all the parts used for this build in the description below. The amplifier accepts voltages from 8 to 26 volts DC, and I was going to use a laptop power supply that delivers 19.5 volts and has a 7.4 x 5mm plug. So I only needed to solder the female counterpart to the amplifier to power it. I've built several DIY projects such as these LED lights and the lap bench power supply that are designed to run with the same PSUs. Laptop power supplies are great for these kinds of projects as they're designed to run all day without overheating, and it's very convenient to be able to interchangeably use the same power supply for different devices. The controllers could simply be screwed into the MDF panels with their threads. But for the pulse width modulator I had to extend the shaft because it was just a little too short to read through the front panel. I did this by cutting a tiny piece of aluminum and gluing it to the shaft, and then gluing 2 shaft pieces of an old potentiometer onto the aluminum as extensions. It was then ready to be screwed onto the front panel as well. Next I prepared the cables to connect the speakers. I used a cable with a cross section of 1.5mm for the drivers and 0.5mm for the LEDs. The cable was going to be 2 meters long, so I cut 2 sections of each cable and the sleeve with the needed length. I fed them through the cable sleeve to have them nicely organized. With heat shrink tube I secured the ends of the sleeve to the cables that they couldn't move anymore. Now that I knew the final cable diameter, I went ahead and drilled the necessary holes for the connection cable as well as the power and the audio plug. I routed the cable through the holes and with a multimeter in beeper mode determined the positive speaker and LED cable and marked it with tape. Next up I prepared the LED light strips to be placed in the housing. I used a 12 volt strip with an amazing 240 LEDs per meter. This strip was perfect not only because it is very bright, but also because it can be cut every 12mm, which make it the perfect choice for working in tight spaces such as these small speaker housings. I cut it to length following the curve of the front panel while making sure to keep the polarity correct. After sticking the sections to the front panel, I soldered them together again. I cut the LED cables to length and soldered them to the LED strips of the front panels. I glued an additional 2 strips inside the housings that they would be evenly lit and connected them with the strips of the front panels. The strips of both housings were going to be connected in series to have the voltage of the power supply. The strips would therefore be only getting approximately 9.75 volts each instead of the 12 volts. This was going to significantly lower their power draw, which was important to keep the heat in check because the LEDs didn't have a heatsink to get rid of excess heat. The power was diverted directly from the amplifier and connected with the pulse width modulators in ports, while the out ports were connected with the LED strips. Also, the left speaker cables were soldered to the amplifier at the same time. This was when the standoffs were coming in very handy because it gave me the option to nicely hide the cables under the amplifier. Any loose cables that would be getting too close to the housing could cast an unwanted shadow that would be visible from the outside. For the volume potentiometer, I used a cable with an angled 3.5mm plug that I cut in half. I determined the left and right audio channels and the ground and extended the cables to reach the potentiometer. I then soldered them to the appropriate connectors for the left and right speaker channels of the potentiometer. This was going to allow me to control the volume with the knob when the audio source was connected via cable, which was going to be the case with my computer. When all the cable routing was done, I inserted the audio and power cable into the holes in the back of the main speaker. I secured all cables and connections as well as the amplifier inside the housings with epoxy glue to prevent any loose parts inside the speakers. When I had checked that all connections were good and everything was working, it was time to join the front panels with the speaker housings. I again used epoxy glue and carefully distributed it around the front panels. Thanks to the notch, the positioning wasn't difficult at all. When the epoxy had cured, all there was left to do was to solder the speaker cables to the drivers. They were inserted into the housings and secured with screws. Last I put the knobs, which I had shortened by a couple of millimeters to make them less protruding on the shafts to finish the build. For the feet I simply used self-adhesive rubber pads that I stuck onto the housings. So there they were, the finished speakers, and I must say that I really like how they turned out. But how do they actually sound? Let's take a listen. For computer speakers they do a great job and are a nice improvement over the built-in monitor speakers. Together with their built-in lighting, they create a very comfortable atmosphere and are a great addition to my desk. I really hope you enjoyed this video. Thank you so much for watching, please leave a comment below and see you for the next project. Bye for now.